We have another example on the board. This time we have NAND gate. Again, we're supposed to find the output waveforms when switch is open and when switch is closed. Please notice that the first input is connected to the pull-up resistor. Okay, so anytime we have this connection, of course to VCC, when switch is open, my first input is going to receive always logic 1. Remember, every connection of the input to VCC directly or by pull-up resistor is going to give me logic 1 at that particular input. Second input is going to receive this waveform. So let's take a look what we are going to have at this moment. Now, we have input waveform, and anytime we want to find the output waveform, we're supposed to draw dash line at every single change of the input waveform. Okay, like always. Now, if you are going to apply 0 to this input, this 0 to this input, and I'm going to have always high at the first input, so 0, 1, 0, 1 or 1, 0 is going to give me always 1 at the output. So I have 1 at the output of my NAND gate. If I'm going to apply, let's say this one, and I have this one, okay, so 1, 1 gives me 0 at the output. So that's why I'm going to write over here 0. When time is coming for this 0, I'm going to have 0, 1, 0, 1 or 1, 0 will give me 1 at the output. Okay, and I have 1, 1, output is going to be 0. I have 0, 1 gives me 1, and I have 1, 1 gives me 0. 0, 1 gives me 1. Okay, so now we can draw the waveform. Please notice that the output waveform of my circuit is nothing else just the complement of the input waveform. Okay, so output waveform when switch 1 is open is simply the inverse of the input waveform. Now let's take a look what will happen with the output waveform when we are going to close the switch. When switch is going to be closed, the current is going to go directly to the ground. And keep in mind that ground has potential of 0 volts. That's why I'm going to have over here always logic 0. Now let's take a look at the truth table of the NAND gate. Anytime, right, we have 0 at any input of the NAND gate, output is always high. Okay, one more time. If you have 0 at any input of a NAND gate, output is going to be always high. So I don't suppose to think too long, just simply draw the line which represents logic 1. Remember, this line represents logic 0. Now, line a little bit above this one is going to represent logic 1. So I can say that these two waves are the solutions to my problem.